convert each of the following numbers from scientific to ordinary notation and write its name. So this is the number 4 times 10 to the power negative 6, which is scientific notation. 4 times 10 to the power negative 6. To write as ordinary, you got to remove this 10 to the power negative 6, and notice that this number is very smaller number because of negative 6 as a 10 to the power. You move the decimal of this 4 to the 6 units to the left. So since you have a decimal after 4, to move 6 units to the left, you add 5 0. So you got 4 0 0 0 0 0 point. So you have if you count here, 1 2 3 4 5 6, 6 units. 1 2 3 4 5 6. That's the ordinary notation. Or you can put 0 here in the front if you like. That's the answer. So how do you name it? To name this is called 4 millionth. 4 millionths. Okay, if you have a, let's say 4 times 10 to the power 6, this is same as 4 0 0 0 0 0 0 as an ordinary notation. We name this as a 4 million, million, 4 million. Because of negative 6 exponent, we say this is 4 millionth. Okay, that's the A. For the B, this number is very big number because of 10 to the power 8. So to write this number as an ordinary, you move this decimal into 8 units to the right. Since you already have 2 units here, 2 and 3, you add 6 more 0. So you get 1 2 3 1 2 3 4 5 6 0. So you have, after decimal, you have 1 2 3 4 5 6 7 8 units. And if you want to write this number as a, if you want to name this ordinary number, you say 100 123 million. Okay, that's how you write. And next questions, you write this ordinary number to the scientific notation. So to write ordinary number, you got to write the scientific notation, you got to write 10 to the power some number format. So for this ordinary number, you have to find the number in the front of 10 to the power, and you have to put the power here and the number in the front of 10 to the power. So what number goes here in the front of 10 to the power? Let's see, since you have this decimal here, you move decimal after 3, you get 3.005. That's what we want to have here, 3.005, because any number if you write before 10 to the power, this must be between 1 and 10, including 1, not 10. So this is the number between 1 and 10. Very good. So by the time you move the decimal 1 2 3 4 units to the right, so you put 4 here, but it has to be negative because this number is very smaller number. The exponent must be negative. Okay, for this number is bigger than one number, so you got to find 10 to the power what going to be here, 10 to the power what going to be here, and what's number in the front of 10 to the power. So to see this, you can see 9.8 as a number supposed to be in the front, so you put 9.8. okay, because the number you're going to put in front of 10 to the power must be between 1 and 10. So I get this number from here, 9.8. But you move the decimal to just 1 unit to the left, so you put 10 to the power 1, but it has to be positive because this number is what, bigger than 1. The 10 to the power exponent must be positive. That's the answer for part B. This is the A, this is the B. How many decimal points you need after decimal depends on the instruction. Here you put 9.8, you can put 9.818 if you like, up to 3 decimal places. It's again based on the instruction. Okay, so that's the question number 24. Okay, multiply or divide. So in this question, you multiply two scientific number. For part A, you multiply 6 times 10 to the power 4 and times 4 times 10 to the power 4. So to multiply this number, you multiply this coefficient of 10 to the power 4 and 10 to the power 4, which gives you 24 times 10 to the power 4 plus 4. Remember that there's an exponent rules. If you have 10 to the power x times 10 to the power y, this is same as 10 to the power x plus y. So you add the exponent. So that's what I did here. So it's gonna be 24 times 10 to the power 8. But notice that 24 is not the scientific notation. You got to write 24 as a scientific form. This same as 2.4 times 10 to the power 1, because the 24 has the decimal points here. After 4, you move decimal between 2 and 4 to write the scientific format. You get 2.4 times 10 to the power 1. Notice that this 24 is same as this number, but the scientific format. Okay, 24 is same as 2.4 times 10 to the power 1, and you have 10 times 10 to the power 8, and altogether gives you 2.4 times 10 to the power 9, because you add 1 and 9 using this rule again. So that's the answer for A. For B, you divide, because this is the division here, so you divide 4.2 times 10 to the power negative 2 divided by 8.4 times 10 to the power negative 5. Okay, first you divide 4.2 and 8.4. If you divide 4.2 by 8.4, what do you get? You get 0.5 times 10 to the power negative 2 minus negative 5. Again, this is the division. So again, I'm going to write the rules here. If you have 10 to the power x divided by 10 to the power y, this is same as 10 to the power x minus y. So if you use the exponent rules for division, that's what it happens. You subtract negative 5. You see, subtract negative 5 from negative 2. That's what it is. This gives you 0.5 times 10 to the power negative 2 plus 5, which is same as 0.5 times 10 to the power negative 10 to the power 3. But notice that this is not the scientific. 0.5 is not the scientific, because this is not between 0 and 1. So I got to change this 0.5 to the scientific. This is same as 5 times 10 to the power negative 1. Notice that this number is less than 1. If you write the scientific number, this is going to be 5 times 10 to the power negative 1. One more time. 0.5 is same as 5 times 10 to the power negative 1. Again, you have a times 10 to the power 3. And if you use this rules, which is multiplication rule for the exponent, you add a negative 1 and 3, and your answer is going to be 5 times 10 to the power 2. That's the answer for this part B. Okay, next questions. Compare the numbers in each pair and give the factor by which the two numbers are differ. So to compare the number, you divide two numbers, 10 to the power 24, which is a bigger number, divided by 10 to the power 18. And if you divide, you get 10 to the power 24 minus 18, because of the rules we just mentioned in previous problem. It's going to be 10 to the power 6, which is 1 million. Okay, so if you want to compare the number, 10 to the power 24 is what? Is 1 million. 1 million times what? 1 million times larger than 10 to the power 18. That's what he said. Okay, that's the answer for part A. Part B, you compare 250 million to 5 billion. So let's write bigger number in the numerator, 5 billion in the top, and for 250 million in the bottom. It doesn't matter which way you do, is this same thing. You can say either this is greater than that, this much greater than that, other one is this much smaller than that. That's the same thing. So 5 billion going to be 5 times 10 to the power 9, and the 250 million is 250 times 10 to the power 6. Notice that billion is 10 to the power 9, million is 10 to the power 6. I write as a scientific format. And if I divide 5 by 250, I got 0.02 times 10 to the power 9 minus 6. Notice that I use this exponent rules. I subtract because of division here, which gives you 0.02 times 10 to the power 3, which is same as 0.02 times 1000. This is same as 20. So I can say that 5 billion is 20 times larger than 250 million. That's why I said. Okay.